In July 1969, nearly 600 million people around the world held their breath and watched a human being step onto another world. But even today, one question refuses to die. Was the moon landing real? Tonight, we're not talking about myths. No conspiracy noise, no dramatic background music, just pure science, real physics, real engineering, real history. And by the end of this video, you'll understand not just what happened, but how it was even possible. Because sending a human 384,400 kilometers away, landing on a world with no air, no water, extreme temperatures, and bringing them back alive, that's not magic. That's science pushed to its absolute limit. Let's go back to the 1960s. The world was divided in a Cold War. The United States and the Soviet Union were racing not just for military power, but for dominance in space. The Soviets shocked the world first with Sputnik in 1957. Then they sent the first human, Yuri Gagarin, into orbit in 1961. America was behind, and badly. Then, President John F. Kennedy made a bold promise. Before the decade was out, America would land a man on the moon and return him safely to Earth. That promise became the Apollo program. The mission that changed history was Apollo 11. The crew, Commander Neil Armstrong, Lunar Module pilot Buzz Aldrin, and Command Module pilot Michael Collins. Now here's where the science begins. To reach the moon, you first need to escape Earth's gravity. Earth pulls everything toward it, with a force defined by its mass and gravity, about 9.8 meters per second squared. To break free, a spacecraft must reach escape velocity, roughly 11.2 kilometers per second. That's over 40,000 kilometers per hour. To achieve that, NASA built the Saturn V rocket, the most powerful rocket ever successfully flown. Standing 110 meters tall, it generated 7.6 million pounds of thrust at launch. When its engines ignited on July 16, 1969, the ground literally shook. But here's something most people don't realize. Rockets don't fly like airplanes. They work because of Newton's third law. For every action, there is an equal and opposite reaction. Hot gas is expelled downward at extreme speeds, pushing the rocket upward. And space has no air, which means rockets don't need air to push against. They carry both fuel and oxidizer on board, allowing combustion and vacuum. After reaching Earth orbit, the Saturn V performed a maneuver called translunar injection. This burn accelerated the spacecraft precisely enough to enter a trajectory that intersected the moon's orbit. Not too fast, not too slow, just right. If they miscalculated even slightly, they would either miss the moon entirely or crash into it. 3 days later, Apollo 11 entered lunar orbit. Michael Collins remained in the command module, orbiting alone. Armstrong and Aldrin transferred into the Lunar Module, named Eagle. Here's the suspense. The moon has no atmosphere. That means no air resistance. No parachutes, no aerodynamic braking. Landing required firing descent engines with extreme precision to slow down. As Eagle descended, alarms started flashing in the cockpit. Computer overload warnings, 1202 and 1201 errors. The guidance computer was being pushed to its limits. It had less computing power than a modern calculator. Mission control in Houston had seconds to decide whether to abort. They chose to continue. Then Armstrong saw something unexpected. The automatic landing system was guiding them toward a boulder-filled crater. If they landed there, the mission would end in disaster. So he took manual control, with only seconds of fuel remaining. Literally less than 30 seconds. Armstrong carefully steered Eagle to a safer spot. And then came the words, "Houston, Tranquility Base here. The Eagle has landed." On July 20th, 1969, Neil Armstrong became the first human to step onto the moon. Buzz Aldrin followed shortly after. Now let's address the big scientific details that prove this wasn't staged. First, the flag appears to wave. Conspiracy theorists say this proves wind, but the moon has no atmosphere, no wind at all. The flag had a horizontal rod to keep it extended. When astronauts twisted the pole into the soil, the flag vibrated and continued oscillating, because there's no air resistance to dampen motion. Second, no stars visible in photographs. Why? Because camera exposure settings were optimized for bright lunar surface and white suits. Stars are faint, just like you don't see stars in daylight photos on Earth. Third, shadows appear at strange angles. That's perspective and uneven terrain. The sun was the primary light source, but the lunar surface reflects light strongly. This creates secondary illumination, altering shadow appearance. Now here's the twist most people don't think about. If the moon landing were fake, it would have required thousands of scientists, engineers, contractors, and technicians to maintain absolute silence for over 5 decades. At its peak, over 400,000 people worked on Apollo. Multiple independent observatories tracked the spacecraft as it traveled to the moon. Even the Soviet Union, America's biggest rival, monitored the mission. If it were fake, they would have exposed it instantly. And here's something even more powerful. Apollo astronauts placed retroreflectors on the moon's surface. These are special mirrors that reflect laser beams directly back to their source. Even today, scientists fire lasers from Earth at those reflectors and measure the return time to calculate the Earth-Moon distance with millimeter precision. You can't fake a mirror sitting on the moon for 50+ years. Now let's talk about the return journey. Because landing was only half the battle. To leave the moon, the ascent stage of Eagle ignited, blasting off from the lunar surface. It rendezvoused with Michael Collins in orbit, a docking maneuver performed entirely in space around another celestial body. After transferring back to the command module, the crew fired engines to escape lunar orbit and begin the journey home. Re-entry into Earth's atmosphere is one of the most dangerous phases. The spacecraft hit the atmosphere at nearly 40,000 kilometers per hour. Friction heated the heat shield to about 2,960 degrees Celsius. That's hotter than lava. The heat shield was designed to ablate, meaning it burned away in layers, carrying heat with it. Without that engineering, the capsule would have incinerated. Finally, parachutes deployed. On July 24, 1969, Apollo 11 splashed down safely in the Pacific Ocean. Mission complete. But here's the shock ending. Something that feels almost unreal. The technology used to land humans on the moon had less computing power than the smartphone in your pocket. In 1969, there were no high-speed processors, no advanced simulations, no modern software. Engineers used slide rules, handwritten calculations, and early computers that filled entire rooms. And yet, they calculated trajectories across hundreds of thousands of kilometers, navigated gravitational fields, and landed on a moving celestial body with astonishing precision. The moon landing wasn't just a victory in the space race. It was proof that human curiosity, physics, mathematics, and engineering can overcome seemingly impossible barriers. And here's the final thought. In December 1972, Apollo 17 became the last mission to carry humans to the moon. Since then, more than 50 years, no human has walked on its surface again. We went, we proved it was possible, and then we stopped, but not forever. Because today, new missions are preparing to return, not just to visit, but to stay. The moon landing was not a myth. It was one of the greatest scientific achievements in human history. And if we could do that in 1969, imagine what's coming next. You're watching Infinite Cosmos,